In this video, let's go ahead and practice applying our understanding of the GCF and the LCM to answer the following questions together. Alright, so for questions 1 through 4, let's go ahead and simplify each of these rational expressions or these fractions using the GCF. Alright, so right away I'm just going to go ahead and use the ladder method. I'm going to take this 42 and 56, just put them side by side and put them in this ladder. In this first step here, I'm thinking of maybe 7 is what goes into both of these as a common factor. We'll be left with 6 and 8. And looking at 6 and 8, I think we have a common factor of 2 between these two numbers, so we're going to be left with a 3 and a 4. All right, so on the side here, 7 times 2, the product here is going to be the GCF. So I'm going to go ahead and say we can go ahead and divide this numerator by 14 and divide the denominator by 14 as well, essentially just using that as the GCF. And then what are we going to be left with as our most simplified fraction? Well, that's just going to be the 3/4 that we see down here. So our most simplified fraction here is going to be 3/4, and we divided both the numerator and denominator by 14, or the GCF, to get there. For number 2, we have another fraction. We have 24 over 72. So I'm going to go ahead and just do the same thing here. Put 24 to the left and 72 to the right. Let's go ahead and see if we can find any common factor that's going to work for both these factors. It goes in evenly. I think I'm going to go with 8 to start here. So 8 times 3 is going to be 24, and 8 times 9 is going to be 72. Now for 3 and 9, we can divide these both by 3, and 3 goes into 3 one time, and 3 goes into 9 3 times. So you can see here that the greatest common factor, or the GCF here, is going to be 24, which means that is the biggest value you can divide both the numerator and denominator by. And if you simplify using the GCF, then we only have to do this one time, and we have the most simplified version of this fraction. So we're going to end up having here 1/3 as our most simplified fraction. All right, cool. So that's just dealing with some natural numbers, or just some regular numbers. Now let's go ahead and try doing this where we have some monomial expressions in the numerator and denominator. All right, so for number 3 here, I'm going to go ahead and write this 28a to the 4th power, b to the 3rd power, and that's going to be over this 84a times b to the 5th power. All right, so let's see what they have in common here. Now, thinking of a number that goes into 28 and 84, I know 2 would work, 4 would work also. I think we could use maybe 14 as well, but I think I'm going to go with 28 here, just because I think 28 times 1 is 28, as well as 28 times 3 is 84. So I'm going to put a 1 here, and I'm going to go ahead and put a 3 here, because 28 times 3 is that 84. And then if we take a look and look at the A's, what they have in common, this one has 4 A's, this one has 1 A multiplied together. You can say they both have an A. And if you look at the B's, the numerator here, I guess, has 3 B's multiplied together, and this has 5. So you can say they both have 3 in common, right? So I think that would be the GCF. If we go ahead and divide this 28a to the 4th, b to the 3rd by this 28a to the 1st, b to the 3rd, I think we're going to still have 3 A's multiplied together over here, and no more B's. When we go ahead and take this 84ab to the 5th power and divide by 28ab to the 3rd power, we definitely have that 3 there. We're going to have no more a's, but I think we're going to have 2 b's multiplied together left here. All right, so we're going to have our greatest common factor over here on the side. That's this 28ab cubed, which means you can essentially divide the top by 28ab cubed. But you can also divide this denominator by 28ab cubed. And again, we can do this because we're being fair and doing it to the numerator and denominator, so we're not really changing the value of this rational expression or fraction. And then what are we left with on the bottom here? On the bottom here, we're going to be left with this 1a to the 3rd power over this 3b to the 2nd power. You don't really have to write the 1 if you don't want to. You can also rewrite this if you'd like, because 1 times a cubed is just going to be a cubed. You can just write a cubed over 3b squared. Up to you if you want to write that 1 or not a big deal. All right. If we take a look at number 4, we have another similar monomial in the numerator and denominator, so we're going to go ahead and try the same process here. So next to each other, let's go ahead and start with this 16x to the 5th power y to the 2nd power, and this is over 72x to the 3rd power y to the 3rd power. So let's go ahead and see what these have in common and find their GCF first. All right, so between 16 and 72, I think we could maybe go with 8 here. I think 8 would probably be the biggest number that goes into both of them. So I'm going to go with 8, but if you need to start with a smaller number, that's fine. Looking at x to the fifth and x to the third, they have three x's multiplied together in common. And then when we look at the y squared and y to the third, they both have two of these y's multiplied together. So I believe I got the GCF right there. We're going to be left with 2x to the second power. And we're going to be left with 9, I think it's just going to be 9y, if I'm not mistaken here. Looks like everything else is going to be pulled out. Okay, so the greatest common factor here is going to be this 8x cubed y squared, which means that's the largest factor you can divide evenly in the top and the bottom. So let's go ahead and just show that we can divide both the numerator and denominator by this 8x cubed y squared. And what would we be left with? Well, we'd be left with this expression on the bottom here. We'd be left with, let's go ahead and write this out. This is going to be 2x to the second power right on top. And we're going to put this 9y on the bottom. So that would be the most simplified way to write this expression. All right, let's try some other types of problems. So in questions 5 through 8, let's go ahead and rewrite each pair of rational expressions using the least common denominator, or the LCD. All right, so a way to use the LCM with fractions is finding out something called the LCD, or the least common denominator. So we're just going to go ahead and rewrite these fractions using the same denominator here. So let's just look at this 12 and this 9 separately for a moment, and let's just find the least common multiple. So 3 goes into both of these. 3 goes into 12 4 times, 3 goes into 9 3 times. So you can see here that the least common multiple is if you just multiply this these outside numbers, or of course you can multiply the diagonals here. No matter how you do this, you're going to find out the LCM, or in this case called the LCD. That is going to be 36. Okay, so how do we get to 36? Well, if you multiply this 9 and 4, that's 36. 12 and 3, it's 36. So 12 times 3 is going to be 36. 7 times 3. Again, whatever you do to the bottom, you got to do to the top. 9 times 4 is 36. We're going to have to multiply this 2 by 4 as well. So what would this these new fractions look like? Well, the first fraction on the left is going to be 21 over this least common denominator, or LCD, of 36. And the second fraction here is going to be 2 times 4 on top, which is going to be 8. And of course on the bottom we're going to have 36. So all we were doing here is rewriting each of these rational expressions, or these fractions rather, so that they have the same denominator of 36. Okay. All right, so for number 6, let's see, we have another pair of fractions here, and they have different denominators. Let's see if we can go ahead and rewrite them so that they have the same denominators, right? So let's see, 16 and 12, they have a 4 in common. 4 goes in 16 4 times. 4 goes into 12 3 times. So we can go ahead and see what the least common denominator here is going to be. If we go ahead and multiply all those numbers on the outside, I believe that's going to be 48, or you can say this is 48 or this is 48. Either way you do it, you're going to get the first time they meet is 48. So 16 times 3 is 48. We're going to multiply the top by 3 as well. 12 times 4 is 48, but make sure we do that on top as well. So for the first fraction, 9 times 3 is going to be 27. That's going to be over 16 times 3, which you know is 48. That's the LCD. That's the first fraction. And the second fraction is 5 times 4, which is 20 on top. And then the 12 times 4 on bottom is going to be 48. So you can see here that both fractions have that common denominator of 48. All right, moving on to number 7 and 8, we have these rational expressions with these monomials on the top and the bottom. What I'm going to do first is actually simplify each of these expressions first, looking at their common factors here, or greatest common factor. So looking at 8 and 15, I think they don't have anything in common, but the a's, it looks like they both have 2 a's, or a to the second power. So let's divide the top and bottom by a squared, right? They both have 2 of them. And then for the b's, it looks like they both have 3, so we can divide by b cubed as well. Okay, so that would be the GCF of this first fraction here. So if you divide 8a cubed b to the 5th power by that a squared b cubed, we're still going to have 8 on top. 2 of the a's were divided out, so we're just going to have 1 a left. And then 3 of those b's got divided out, so we're going to have b to the 2nd power. All right, so that's going to be the numerator. As for the denominator, the 15 is going to stay down there, right? We didn't do anything with the 15, but it looks like both a's were divided out, and then all 3 of those b's, b to the 3rd power, was divided out as well. So I'm actually going to take this 15 and just move it to the middle of our fraction bar. So there's actually no more variables in the denominator. Now, as for the second fraction, let's go ahead and see what they have in common. 5 and 9, I don't think they have anything in common here. Okay, so what about the a's? Well, it looks like they both have a squared, or they both have 2 a's that are multiplied together in there. And then it looks like the top has 1b and the bottom has 2b's, so we could say they both have 1b. So if you divide that numerator by a to the second power times b, you're still going to have this 5 here, but I think everything else is going to cancel out. There's going to be no more variables on top. And on the bottom, we're going to still have this 9. That 9 is going to stay put. And then we had 4 of those a's multiplied together, but we divided 2 of them out, so we still have a squared. And then we had 2 b's down there, we divided by 1b, so one of the b's is going to cancel out here. All right, so at this point, these fractions are definitely a little bit more clear, so they're a little bit less cluttered. We simplified them a bit, so we're just gonna have to find the LCD between these two denominators here, right? So let's go ahead and take this 15 and this 9a squared b. And let's go ahead and see if we can find the first time these meet. Well, they don't both have any letters in common. I think they really just have this number of 3. So 3 times 5 is going to be 15, and 3 times 3a squared b is going to equal 9a squared b. So what is the LCD? Well, the LCD is going to be the product of these factors here. So the LCD here is going to be 3 times 5, which is 15, times 3, which is going to be 45a squared times b. All right, so how are we going to get there? Well, this 15 is going to have to multiply by 3a squared b. Let's go ahead and write that. It's going to be times 3a squared b. But if you do it on the bottom, you also have to do it on top, times 3a squared b. Now for our other denominator, we have to multiply this 9a squared b times 5. So let's go ahead and write this. Got to multiply by 5 and multiply by 5. So how are we going to write these new fractions? Well, if we multiply this 3a squared b by this 8ab squared, 3 times 8, let's see, 3 times 8 is going to be 24. A squared times a is going to be a to the third power, and then b times b squared is going to be b to the third power. And of course, this is going to be on top of our LCD that we got, which we said was what? 45a squared b. All right, that's that first fraction. And for the second fraction, we have this 5 times 5, which is 25. And of course, it's over that same common denominator of 45a squared multiplied by b. So these would be both versions of these rational expressions, but using the same denominator of 45a squared b, or the LCD. All right, for number 8, let's go ahead and see if we can do the same sort of process. If you want to pause and give it a try on your own, feel free to do so. For number 8, it looks like the 7 and 8 have nothing in common, but it looks like they both have 2 x's we could divide by. So let's divide both top and bottom by x squared. Okay, and then for the y's, the top one has 1 y and the bottom one has 5, but you can say they both have 1 y in common. So if we go ahead and divide the numerator by this x squared y, we're still going to have the 7 here. We had 3 x's, 2 of them got divided out, so we have 1 x left. We had 1 y, we divided 1 out, so there's no more y's there. Now for the denominator, the 18 is going to stay put. Couldn't really do anything there. Both x's are being divided out, so x squared divided by x squared is just 1, so we don't need to write that. And then y to the 5th power divided by y, we're getting rid of one of those y's. It's going to be y to the 4th power. All right, what about that second fraction? Well, let's see. The 8 and 15 have nothing in common. The top has 5 x's, the bottom has 3 x's multiplied together. We can divide both top and bottom by x to the 3rd power. Let's go ahead and divide both of them by x cubed. And then for the y's, the top has 2 y's and the bottom has 1 y, so we can divide top and bottom both just by 1 y here. All right. If we divide the 8x to the 5th power times y squared by this x cubed y, the 8 is just gonna kind of stay put here because we didn't really do anything with those coefficients or those numbers. We're going to be left with x squared y. That's going to be the left of the numerator. In the denominator, we're going to have this 15 here. And I think everything else is going to get canceled out. So I'm actually just going to go ahead and move this 15 and put it in the middle of that fraction bar. So we have these 2 different fractions. They're a lot simpler now. Let's see if we can find the least common denominator between these 2 expressions. All right, so looking at this 18y to the 4th power and 15, in common here, I think they both have a 3, right? So 3 goes into 18 6 times, it's going to be 6y to the 4th power, and 3 goes into 15 5 times here, right? So I think that's all that they have in common. So our LCD is going to be the product of these factors here. So the least common denominator here, it looks like, is going to be 90y to the 4th power. Okay, so how are we going to get there? or we're going to take this 18y to the 4th power, multiply it by 5, right? So we can go ahead and write it's going to be times 5 times 5, okay? And then for our second piece here, this 15 is just going to multiply by 6y to the 4th power. So let's multiply this by 6y to the 4th power over 6y to the 4th power. So rewriting these, we're going to get 35x over what? Over 90y to the 4th power. That's going to be one of our rational expressions. And for our second rational expression, 6 times 8 is going to be 48. And then we have this x to the 2nd power. Then we have y times y to the 4th power, means we have y to the 5th power. And this is going to be all on top of what? 15 times 6. So it should be the same common denominator of 90y to the 4th power. So there you have both of these rational expressions, with these monomials written using the least common denominator. So now that we practiced some of these background skills, let's go ahead and put these together and try adding and subtracting some of these expressions together. Make sure we're going to go ahead and use LCDs, or the least common multiple of the denominators, so that we can go ahead and add and subtract these expressions. And then if we can, we should always simplify using the GCF after. All right, so looking at number 9, we're just going to be adding these two fractions together. We have 8 and 10. The first time 8 and 10 meet are going to be at 40, I believe, right? So I'm going to go ahead and write on the side here. If you want to write out the work to find out the LCD, feel free to do so, but I'm just going to write it if it's easy enough to do so. So the first time 8 and 10 meet is going to be at 40. So 8 times 5 is going to be 40, so I'm going to write times 5 times 5. And then 10 times 4 is going to be 40, so I'm going to write times 4 times 4. So these new fractions are going to be 3 times 5, which is 15 over this 40, plus, and then 3 times 4 is going to be 12 over 40. All right, so notice we do have these common denominators now, so we are given the green light. We're good to add these two fractions together. 15 plus 12 is going to be 27, so we're going to get a final expression here of 27 over 40. I don't think we can simplify this at all, just because they don't have any common factors in the numerator and denominator besides 1. Okay. We take a look at number 10. For number 10, we have this 5/9 minus the 1/6. When do 6 and 9 meet for the first time? Again, if you want to write out the work or make the ladder method or prime factorization, you can list them. I think it's going to be at 18. Okay, so I know 9 times 2 is 18. So make sure you multiply the top by 2 as well. And then 3 times 6 is 18. So multiply the top and bottom by 3. So 5 times 2, that's going to be 10. So we're going to have 10 over this 18 minus, and then 1 times 3 is 3. So we're going to have 3 over 18. Now that we have these common denominators of 18 and 18, we can subtract 10 minus 3, which is going to be 7. So we're looking at a final answer here, or our difference is going to be 7/18. All right, let's check out number 11. For number 11, looks like we have some mixed numbers here. Same idea kind of is applied here, though. You can just ignore the whole numbers for now. Let's look at 9 and 15. 9 and 15, they're going to meet for the first time at 45, I believe. All right, if you want to go ahead and pause and figure that out, feel free to do so. But 9 times 5 is going to be 45, all right? So make sure you multiply the top by 5 as well. And then 15 times 3 is going to be 45. So make sure we multiply the top and bottom both by 3. So our first mixed number is going to be 5 and 35 over 45. And then our second fraction here is going to be 3 and 21 over 45. All right, so when you add mixed numbers here, first you can just go ahead and add the whole numbers. So 5 plus 3 is going to be 8. The denominator is definitely going to still be 45. But if you go ahead and add the numerators of 35 and 21, that's going to be, what, 56, I think? Yeah, 56. Now, turning this into a mixed number that doesn't have an improper fraction in it, this is going to be basically saying what we have 8 and 45 45ths, plus how much extra do we have? Looks like we have another 11 over 45, right? That's another way you can think about it. I just broke up this 56 into 45 plus 11. Keep in mind this 45 over 45 is just 1, so 1 plus 8 is going to be 9. So we can really say this is going to be 9 and 11 45ths. This would be our final answer. All right, for number 12, let's go ahead and see if we can find the difference or the answer to this subtraction problem. So let's go ahead and see here. We have this denominator of 8 and 6. I think they're going to meet for the first time at 24. But again, feel free to pause if you want to think about that for a bit. So 8 times 3 is going to be 24. So multiply top and bottom by 3. 6 times 4 is going to be 24, so multiply top and bottom by 4 here. So we're really going to here have 7 and 3/24. I'm going to go ahead and take away here, what, 3 and 20/24. So what we're going to do here is we'd like to just go ahead and subtract. We can do 7 minus 3, that's fine, but this 3 minus 20 is a little tricky here. So I'm going to go ahead and do this thing called borrowing from the whole number. So the 6 here, let's go ahead and take one whole from it. And let's go ahead and regroup and add 24/24 to this 3/24. So again, 24/24 is just one whole. So we're really just kind of moving 1 from the 7 over to the fractional part here. So adding 24/24 to the 3/24, that's going to be 27/24, right? So I know it looks a little funny. We put a improper fraction in a mixed number, but it's just temporarily, okay? Just so that we can subtract and have it make a little bit more sense, hopefully. All right. So at this point, we can just go ahead and say 6 minus 3 using the whole numbers is going to be 3. And then for the fractional parts, 27/24 take away 20/24 is going to be 7/24. This is right here is going to be the answer to this problem. All right, looks like number 13 got put in a weird spot here. I'm just going to go ahead and do it here, but I'm also going to just kind of move it up in a little bit. So let's see, we have these denominators of 8 and 10. All right, so let's go ahead and see the common denominator here. 8 and 10 are going to meet for the first time at 40. I think we did one earlier, kind of similar with these denominators. So 8 times 5 is going to be 40, so multiply the top. Then 10 times 4 is going to be 40, so let's make sure we do that on top and bottom as well. So I'm going to write my work down here and just move it where we have more space in just a second. But this is going to be 4 and 35/40. And if we're going to go ahead and add the second piece together, it's going to be 5 and 12/40. All right, so we can go ahead and add these now that they have the same denominators. So let's see, 4 plus 5 is going to be 9. And then if we go ahead, we're definitely going to have 40 in the denominator here. But for this 35 plus 12, that's going to be 47. Okay, so rewriting this as a mixed number that doesn't have this kind of improper fraction kind of awkwardly inside of it, we're going to have 10 wholes and then 7/40, right? So we just kind of regroup there because there was a 40/40 inside of that 47/40, which is really just 1. So I kind of just moved that back over to the, added onto the 9 to get to that 10 there. So it's going to be 10 and 7/40. All right, let me go ahead and just move this right over here and just draw an arrow so we know where that came from. In number 14, we have a difference here. We're going to be subtracting. Notice that we have these different denominators. So what's the first time 3 and 9 are going to meet? Well, I think it's going to be just at 9. So I'm going to say that least common denominator is going to be 9 here. The 3 can just multiply by 3, top and bottom. And then the 9, we can just leave it alone, or we can also just write it so it's consistent and say we're going to multiply top and bottom by 1. So this new versions of these fractions is going to be 6 and 3/9 minus this 2 and 7/9. All right, so we'd like to subtract, however, 6 minus 2 is fine, but this 3 minus 7 is a bit problematic. Let's go ahead and borrow for this first fraction. Let's borrow from the 6 here, make it 5, and move over 9/9 to the 3/9 to make it 12/9. So we have 5 and 12/9 minus this 2 and 7/9. All right. At this point, I think we're good to go, right? This 5 is bigger than the 2. The 9 is just going to stay on the bottom, and the 12 minus 7 is going to be okay too. So 5 minus 2 is going to be a 3 for the whole number. 12 minus 7 is going to be 5 for the numerator, and our denominator, of course, remains as being 9. That will be our answer. All right, let's check out number 15 and 16. We're going to deal with some monomials and some rational expressions. First, let's go ahead and just simplify each of these fractions or rational expressions on their own. For the first fraction, I'm going to divide top and bottom by x squared y squared because that's the greatest common factor. Again, if you need to pause to think about that, feel free to do so. If we go ahead and do that, this same fraction, but in simpler terms, is going to be 5x to the second power over 3y to the third power. Okay. Now what about that second fraction or the second rational expression? Looks like you can divide top and bottom both by 2, right? Because they're both even numbers. We can also divide x squared from both, and I think y cubed from both. All right. So the bottom we can also divide by 2x squared y cubed because that's the greatest common factor of the top and the bottom, right? If we divide both top and bottom by this 2x squared y cubed, in the numerator we're going to be left with this 2, and on the denominator, or in the denominator, we're going to have 3 I think just x squared. I think that's it. All right, so you can see these expressions are definitely simpler than they used to be. If you look at their denominators, they're not too different from each other. The 3's are actually quite nice already. You can see the one on the left doesn't have the x squared, but the one on the right doesn't have the y cubed. So what's the LCD here going to be between those two expressions? Well, I think they both have a 3 in common, right? And then they're going to need this x squared and y cubed. So they both want to have that for the denominator. So the one on the left here is missing the x to the second power. So let's go ahead and multiply top and bottom by x squared. And one on the right, I think it's missing the y cubed. So let's go ahead and multiply top and bottom by y to the third power. Now if we go ahead and take care of that, we're going to get this 5x to the second power over what? Over this 3x to the second power y to the third power plus, and then on the top here we're going to have 2y to the third power, and on the bottom here we're going to get 3x squared y cubed. All right, so that would be our two fractions that have the same denominator here using that LCD. And since they have the same denominator, we can actually add these two together or write it as one fraction. So we can just write 5x to the second power plus this 2y to the third power, and that's going to be all over this 3x squared y cubed, also known as the least common denominator between these two expressions once we had simplified them from the beginning. All right, so multiplying these and getting those common denominators, on the first numerator, we're going to have this 5x to the fourth power. That's going to be over this 3x squared y cubed. And then for the second fraction, we're going to have 2 times y to the third power, or just 2y to the third power. This is going to be on top of 3x squared y cubed. So notice here that these now have common denominators, and it's the least common denominator between these two expressions. But because they have the same denominator, you can now rewrite this as one fraction. So we can write 5x to the fourth power plus 2y to the third power. We can't really do much with that. We're just going to leave it just like that. And in the denominator, we're going to have this 3x squared y cubed, right? So this would be that least common denominator. This, though, would be our most simplified way to write the sum, or write this as one fraction or one expression when we're done here. All right, let's try one more problem here. For number 16, let's go ahead and see if we can simplify first as well. On top and bottom, I think we can divide both by, we've got to leave the 3 and the 8 alone. We can divide by a squared b cubed. I think we can go ahead and do that on both top and bottom, divide by this a squared b cubed. If we do that, this more simplified version of this first expression is going to have this 3 still. We're going to have an a in the numerator, and we're going to have one more b left. In the denominator, though, we're going to still have the 8 here. I think the a squared and b cubed are both going to be canceled out here. So I'm going to move this 8 into the middle of that fraction bar. Okay. Now, what about that second expression? The 5 and 12 have nothing in common. The top and bottom both have an a, so we can divide both by a. And I think they both have 3 b's multiplied together. So we're going to divide both top and bottom by ab to the third power. All right, so if we go ahead and do that for this numerator, we're going to get this 5. I think the a's are going to cancel out, and then the b cubes are also going to cancel out, so they're all just going to become 1. And in the denominator here, we're going to have this 12 for sure, and it looks like the a's are going to cancel out and become 1, and then we're going to have this 1b left for the denominator. So right now, this is definitely simpler than what we had before. We have these two different denominators, which means you can't write it as one using only one fraction bar just yet. So let's go ahead and find the least common denominator between these two denominators here. So I believe 8 and 12 meet for the first time at 24, and they both have to have a b on the bottom in order to have those common denominators. So let's see, the 8 needs to multiply by, let's see here, the 8 needs to multiply by 3b. If we multiply this by 3b, we'll get 24b. If we multiply this one by 3b, we'll also keep this even or consistent if you do it on top and bottom. And then the 12b needs to multiply by 2, and so this 5 also needs to multiply by 2. All right, so our new numerator here is going to be 9ab squared. That's going to be over this 24b minus, and then 5 times 2 is 10, so we're going to have 10 over this 24b. All right, so notice we rewrote these fractions, and they also have common denominators now, specifically the least common denominator. And if we want to go ahead and just write this using one fraction bar, we're allowed to now because they both have the same denominator. So we have 9ab squared minus 10, and this is all over 24b. This would be how we could write this difference of these monomial rational expressions using just one fraction bar. And we can do that now just because they have the same common denominator. All right, so there you have 16 different practice problems where hopefully you got a little bit of practice where you could simplify these rational expressions or fractions using the GCF, but also you also practice kind of rewriting sums and differences or answers to addition and subtraction problems using the LCM, which is really just an LCD form, least common denominator, or which is an application of the least common multiple. So if you find the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.